So here's the video I've been trying to work on. So for the honors chemistry, I know that the professor from IU goes over this, but I want to kind of show you some simple conversions and point out some of the stuff we really expect you to know. One way of looking at this is if we have some numbers, and I know this is slightly messy, is if we're looking at this, if 0 is your base, in the ones place is your base, then 0.1, okay, then 0.01, so this is in the tenths, the hundredths, the thousandths, the 10,000ths. Up here, this would be, the 1 would be in the tens place, this would be in the hundreds, thousands, 10,000s, 100,000s, and the millions. So when we start looking at this, we need to understand that yes, the 0.1 is a deci. 0.01 is in the centi, the 0.001 is milli, and then once we get down here to 0.000001, that's a micro. Going up, the base 10 is deca. We probably won't use that very much. 100 is hecta. We won't use that much, if ever. I don't think we'll use that. But we do need to know that 1,000 means a kilo, and that 1 million is a mega. We won't use that 1 billion is a giga, but just kind of for random knowledge sake, yeah, that is a giga. The easiest way to think about that is in bytes. We'll talk about that here in just a second. But if we bring this out, if your base unit, if this is here, this would actually be a 0, but a 0, if we would have made this a 1 instead, I guess. This a 1 for the base unit. 1 times 10 to the 0, anything to the 0 power is 1. 1 times 1 is 1. So then 1 times 10 to the first power, 10 times 1. So be able to go from this to this. And so if we look at the base unit is 1 times 10 to the 0, kilo is 1 times 10 to the 3, mega is 1 times 10 to the 6th, giga is 1 times 10 to the 9th. Again, you don't have to know mega and giga, but we do expect you to know kilo, your base unit. We do expect you to know centi for centimeters. We probably won't use decimeters much. We do need to know milli or milli. That's 1 times 10 to the negative 3, so anything in decimal form. This is another way to look at it. You do need to know micro. The other parts of this is, if this is your base unit, we need to understand that this has the abbreviation of a lowercase k. Okay, this is a lowercase d. The deca, if you ever were to come across that, is going to be DA. Hecta, I believe, is an H or an HA sometimes. This is a lowercase c, lowercase m. Because the micro is m, and this is also an m, we use the, I believe it's the mu, which looks like a cursive U. So that's going to be the micro, making sure you can see that. Hopefully you can see that on this. Okay, maybe you couldn't see that on there, but this is the micro. So 1 times 10 to the negative 6. So again, what I was saying, of course this would be the mega. This is a giga, all right? Those are uppercase. Once you get above that, those are uppercase letters and abbreviations. So probably not going to need to know this one. Not need to know this one. Rarely are we going to need to know this one, but we definitely need to have these memorized. The K for kilo, C for centi, M for milli, and the mu for micro. So again, one of the things I was talking about is, let me see if you got this. If we're talking about a byte of information in computer science or programming, 1 byte of information is 1 keystroke or something like that. I'm not a computer scientist, but if you have 1,000 of those, that's a kilobyte. If you have 1 million of those, that's a megabyte. If you have 1 billion of those, that's a gigabyte. So if you're understanding some of that, and then some people may actually understand and know what's above a gigabyte. Well, that's going to be 1 times 10 to the 12 bytes of information. That's going to be a terabyte. And if you go to 1 times 10 to the 15, this is a terabyte. This is going to be I believe it's a petabyte. And then 1 times 10 to the 18. You can look this stuff up. Again, you don't need to know it. It's just kind of curious. I think that's an exobyte. Exobyte, and then times 1 times 10 to the 21st, which is the next, is like a zettabyte, and then a yottabyte, or whatever that would be. So those would be in your, definitely your supercomputers. Now, kind of hard to have less than a byte of information, I believe. But if we were talking about something like a meter, so we can have a decimeter, a centimeter, millimeter, micrometer, and so on and so forth. And of course, we need to talk about that a little bit. So this is going up and down. Another way to show this is going side to side. This was shown to me, and you may have to zoom in or look very closely on this, but this was shown to me by a student one time, how they were explained to it, or they found it on Neil deGrasse, or one of their parents showed them this. But again, we understand that this 1 is in the 10th place. The 0 is in the base unit. So this is the 1 in the 10th place. And so that would be if we're talking about grams, this would be a decigram. So if we're talking about these in grams, this placeholder represents 1 decigram, or a DG. So this is in the 100th place, so this would be 2/100ths of a gram, or centigrams. This would be in the 1,000th place, and so that would be 3 milligrams, so it's an mg. And then this would be 0.4, we would say this is 0.4 milligrams. This would be 0.05 milligrams. Sorry about that. But now once we get to here, this would be a microgram, or 6 micrograms. This would be 0.7 micrograms. 0.8. I'm sorry again, I did it wrong again. 0.08 micrograms. Once we get to the 9, now we get into another one I expect you to know, which is nano. Nano, so it'd be a lowercase ng for a nanogram. Okay? And so then even after that, if you get into enough biology, we start talking about how wide different membranes are, we might get into something called an angstrom. And that has the A with a little halo at the top as its designation. And so that's an angstrom is 1 times 10 to the negative 10 meters. Wouldn't be in grams, that would be a distance. So that would be meters. Once we get out here to 12, after a nano is a pico. So this is a pico, a lowercase p, so it'd be a picogram. And if you went on past that, then there's a femto, an atto, a zepto, and I think it's a yetto. But what we really want to know is, do you understand kilograms? We need to know really down from megagrams. Definitely need to know kilograms. Definitely need to know definitely need to know centigram, milligram, and micrograms, and possibly nanograms. Again, why did I show you this? Is because this is another way to look at and memorize this. Because these numbers, the way they've been written out, this would be, because this is the base unit, this would be 1 times 10 to the 0. This would be 1 times 10 to the negative 1. Don't get confused here. So this is a 2 in this 2 spot. So yes, this is the hundredths. So this is 1 times 10 to the negative 2. Or in this case, this would be 2 times 10 to the negative 2 for this actual digit. But if this was a 1 right here, if this was a 1, it would be 1 times 10 to the negative 2. If this was a 1, it would be 1 times 10 to the negative 3. If this was a 1, it would be 1 times 10 to the negative 4. So if you can kind of understand, if you wrote it out this way, you could count how many units over. This tells you how much negative this exponent would be, putting it into scientific notation. So if we go in here to a nanogram, we automatically know that 1 nanogram, not 9 nanograms, but 1 nanogram is nanogram is 1 times 10 to the negative 9. Okay, so that would be a nanogram, okay, which actually is so many grams. Sorry about that. So 1 times 10 to the negative grams is equal to 1 nanogram. So then again, this is your base unit. This would be a deca, a hecta, and this is into the thousands. So now we're into the kilo. So again, if we're going out to thousands, all of a sudden we're talking about 1 times 10 to the 3, because this is your base, but you've gone up. And so you got to remember that 0 there. Kind of an important thing that the ancient Indians did from the country of India. I believe they come up with the idea of 0. So as we move back and forth, this would be, if this is a kilo, or if this was a kilogram, then after that would be a megagram. So that would be mg, or 1 times 10 to the 6 grams. 1 times 10 to the 6 grams is 1 megagram. So now let's look at this just a little bit further. Let's do one little conversion here, okay? And so let's say I have 273.4 micrograms. And I want to convert this to kilograms. Now there's several different ways to do this, but I want to kind of show you this. I need to start here, 273.4 micrograms. Can micrograms be in my answer? No. What has to be in my answer? Kilograms. I know that kilograms has to be in my answer. Okay, so I'm going to write that down. I know that I have to get rid of micrograms somehow. Now I can go just to grams. If I go to grams, then I can do this. And knowing that, I know that if micrograms, okay, micrograms is 1 times 10 to the negative 6. So how many micrograms is in a gram? Here's the hint. Here's the hint. Whichever is largest becomes 0. A microgram is much smaller than a gram. I said that wrong. Whichever is largest becomes 1. Now, how many micrograms does it take to make a gram? So looking at this, you've got to have this memorized. It's going to take how many micrograms? Okay, this is tens, hundreds, thousands, 10,000s, 100,000s, millions. It's going to take 1 million micrograms to make 1 gram. So I'm going to say that this is 1 million. Now you can do that, or you can say 1 times 10 to the 6th. Now I know we were talking about how that was a negative times 10 to the negative 6, but that was only if you're talking about how many grams. This is number of micrograms. It's 10 to the 6 micrograms in 1 gram. Well, that gets rid of my micrograms. Still doesn't give me the correct answer. I've got to get rid of grams. So I got to put grams on the bottom. Kilograms is on the top. So here's my next step. Which one of these is larger? Whichever one is larger becomes 1. Kilogram is larger. Well, how many grams? Well, that's 1 times 10 to the 3rd. That's 1,000 grams make 1 kilogram. So far, we're doing okay, I hope. So that being the case, now I'm going to multiply across the top. 273.4 times 1 times 1 is 273.4. Okay, 273.4. Now we're going to do this. We're going to divide by these numbers. This is times itself. So I have 273.4 times 10 to the 0. Would you agree with that? So now I have 1 times 1. If we're multiplying, we're adding the exponents times 10 to the 9th. Here's what we do. We split this apart. 273.4 divided by 1 times 10 to the, here's what we do. We made this simple. When dividing, here's top and bottom, so you're subtracting the bottom one from the top. 0 minus 9 is a negative 9. So our answer is going to be 273.4 times 10 to the negative 9. Now in correct number significant digits, we're going to go over 2. So this is 2.734 in scientific notation, but as I go to the left, this is now going to be 2.734 times 10 to the, since I went up, negative 7. And this is going to be in kilograms. So hopefully that wasn't too confusing. Maybe you found something out of that that you can use. If I wanted to shorten this up and I know the direct conversion, you can easily do this. 273.4 micrograms. If I look this up, for every microgram, there's so many kilograms. Which one is largest? Kilogram is larger, make that a 1. How many micrograms are in 1 kilogram? Well, it took 1,000,000 of them to make a gram, right? It took 1,000,000 micrograms to make 1 gram and another 1,000 grams to make a kilogram. So there's actually 1 billion. So you could have put down here 1 times 10 to the 9 micrograms make 1 kilogram. Gives you the exact same answer, okay? That's the hint to make it the easiest way. You can, I'm not going to tell you you're wrong when doing this because some of you guys are really good at math. You can say this, 273.4 micrograms. 1 microgram is equal to 1 times 10 to the negative 9 kilograms. It is 1/100000th of a kilogram is equal to 1 microgram. I just think it's harder for my mind to wrap around getting through these whenever we're canceling things out, whenever we get into more difficult ones. I just wanted to let you know one of the hints to a lot of our conversions is whichever one is the largest becomes the 1, and then fill in how many of the others there are. So hopefully this helps. If it confused you more, shoot me an email and I will apologize directly to you.